Hello everyone, this is Ni Xiaoyong from Beijing Normal University. It is really a great honor for me to have this chance to share my research study on the characteristic laws of urban road traffic flow under rainstorm and waterlogging. I'd like to share my research as follows: background, framework and methods, results, summary, and prospect. The events of rainstorm and waterlogging are very common in cities. As a recent case in China, more than 300 people died in this year's rainstorm in Henan, Zhengzhou. In our study, we mainly focus on how exactly the rainfall and waterlogging would affect the transportation system at different levels, including drivers, traffic flow on single road sections, and traffic flow in networks. Another question is that what we could do with the support of from-edge driving simulator and using WinRoad. As to the framework and methods, our study includes 3 sections. Section 1 is the driving simulator study. Section 2 is traffic flow simulation on a single road section, and section 3 is traffic flow simulation on multiple road sections. In section 1, a dataset of vehicles track from the experiment is produced, and section 1 is the basis for section 2 and section 3. The results from section 2 are the input of VCTM in section 3, so section 2 is also the basis of section 3. Let's go into the results part. As to the section 1, we have conducted an experiment. A total of 47 valid participants were recruited in this experiment. 30 scenarios are designed according to different rainfall intensity and water depths. In each scenario, 3 periods are set one by one, including free acceleration, forced deceleration, and car following. This figure shows the feature of vehicle's velocity during the experiment quantitatively. Increase of rainfall intensity and water depth would induce the decrease of velocity. We also found that if waterlogging does not exist, then the rainfall intensity has more significant influence on vehicle speed, and vice versa. Similarly, rainfall and waterlogging both have significant effect on vehicles' acceleration and deceleration. This work has been submitted to a SSCI journal TBS and now is in a state of under review. In section 2, we focus on traffic flow simulation on a single road section. There are 3 steps to calculate the result, including calibration of car flowing models, traffic flow simulation, and simulation result fitting. In total, 5 car flowing models are selected as candidates. High-performance GA was utilized here to calibrate the unknown parameters in all the 5 models. As a result, it is found that IDM performs the best in general. Follow-up research is carried out based on IDM. This is the scene setting in the simulation. Monte Carlo method is first used here to determine the drivers, and then the simulation is conducted in an order of acceleration, calculation, and vehicle movement. It is found that free flow velocities decreases with the increased rainfall intensity. We also found that the capacity of the road generally decreases with the increase of rainfall intensity. This work has been published in a SCI journal, JTEPA. In section 3, we focus on local transportation systems and networks. As a case study, a 120-minute long rainfall with a return period of 5 years is taken as an example in this section. A downtown area in Beijing, China is selected as the study area in this section. As shown in these figures are the road network, buildings, rainwater drainage system, and DEM data in the study area. One pipe flow model and a 2D hydraulic model are proposed here as the integrated simulation tool for the waterlogging. We can find that many waterlogging points are located on the road as a result. This work has been published in an EI conference, ISCRAM 2021. Then we go into the latter part of this section. We proposed a novel VCTM considering the effect of rainfall and waterlogging. Free flow speed, capacity, and backward propagation speed are 3 key parameters in VCTM. Their correlation to rainfall and waterlogging has already been reviewed in these 3 formulas. Take a local view of the network composed of 7 road sections. It is found that rainfall could have significant influence on flow when the traffic capacity of some road section is insufficient. Moreover, it is found that waterlogging will induce flow fluctuations near the ponding seals. This work has been submitted to a SCI journal, JTEPA, and now is in a state of under review. In summary, 4 relevant research papers have been finished in this project during the past year. It proves that from a driving simulator and use simulator can not only be used as APP developing tools but also are very powerful platforms to support scientific research. Thank you.